Hello, everybody, and welcome to my session on measuring DevOps success with pipeline analytics. Before I start, I just want to say I know there's a lot of content out there today, and everybody is probably getting sick of being stuck behind their monitor in their home offices here. So you taking the time to join my session, I really appreciate that. And also, big thank you to everybody at CD Foundation. Putting these events together is a lot of work. So if you get to engage with anybody at the Linux Foundation or CD Foundation, please tell them how much you appreciate this content. So I want to start out briefly with a story and put you in the right mindset about why pipeline analytics is so important. If you are at this conference, then velocity and automation is already your jam. That is what CI/CD is about. But let's say you got a chance to drive your first F1 car. And they said, it's yours. You take it, you drive it as fast as you want, wherever you want. So you hop in and you ask, all right, where's my helmet? They say, no helmet, no visor. You say, okay, what about a seatbelt? No seatbelt, you don't need that. And then you look in front of you, and what you see is a country dirt road. So while you have the best, fastest machinery you could possibly find to go fast, you quickly realize that you're not going to feel too comfortable doing that unless you have the tools you need to be successful. And so when we think about DevOps and CI/CD and most of the conversations we have, we often talk about velocity and automation, and we all enjoy that. None of this is negating the importance of velocity. But is DevOps really just about going fast? Or is it about going fast in a meaningful way? Setting yourself up with that F1 and being able to use that velocity and all that power behind you, but in a sustainable and long-term way. Because a lot of organizations have the F1 in their hands as a tool to use, but don't get that far or find out very quickly that that velocity has created more problems than benefits. My name is Chris Riley. I am a senior technology advocate at Splunk, focused on developer relations and DevOps. If you want to find out more from me, you can scan that QR code. It'll give you access to my various podcasts, or just reach out and tell me what I said right or said wrong. I don't really care. I love hearing from people who attend my sessions. So before we begin, let's set the steady state of where most organizations find themselves when it comes to visibility across their software delivery chain, which I probably will reference as the SDLC here on out. Teams can be very good at creating visibility for themselves. So for example, developers tend to be very good at using tools to understand what's going on in their build and test processes and visualizing those. And they really enjoy doing that. DevOps engineers tend to be really good at visualizing access and activity across the tools that they're using. And some of that telemetry and data and visualizations come directly from the tool itself. And then especially once we hit production, we are very experienced and good, or SREs, DevOps engineers, operators, security professionals are very good at visualizing their slice of what happens in production. So I'm not here to say that teams are failing at visibility within their domain. What enterprises and whole engineering teams are failing at is reconciling the language and the visibility across these silos. Because every time a developer has to stop and explain a dashboard for their, for example, vulnerability scans to a security professional, that stops everything for a long period of time. So it's not beneficial to have these visibility silos where a handful of people deeply understand what's going on, but nobody else. Because anytime you have to go and explain to another person in the broader engineering organization what is happening in your realm, it's just wasting time. It doesn't need to happen. And if you love automation, you know that's why we automate. So think about visibility exactly the same way. And the reason you should think about it exactly the same way is your software delivery chain is an application. Anymore, if you have focused on automation first for deploying your applications, which I know you have because you're here. you're thinking about CI/CD in a deep way. Then you're actually thinking about your delivery chain as a product, as an application of applications, the meta application. Well, that means that you should treat it exactly the same. So it should have features. It should have features whose customer is the developers, the SREs, and everybody else in the development organization. If you're attending today and you're a developer, you get to consume this data in such a way that it reduces the amount of time of unplanned work for you. If you're a DevOps engineer, you're probably the deliverer, the owner of this product. Maybe it's a monitoring organization. If you're the SRE, this product is what helps give you more context for production incidents. And if you're a security professional, it gives you more visibility and confidence in what's happening along the software delivery process. So it is an application. It is an application that you are delivering to the rest of the organization. Your customers, not just your developers. It's the process of shipping code. Because it is an application, it should be operable, it should be securable, and it should be measurable. These are all elements to ensure that that velocity that you have created is sustainable. You can maintain it, and you can tell somebody whether you're doing a good job or a bad job, which is the lifeblood of career growth and maintaining and justifying why you do what you do. I like to use this term called code to cloud visibility. This is why we do all of this. And like I said earlier, we tend to be already pretty good at what happens in production. We have this new term, observability, that represents monitoring distributed and modern applications in production. We're really good at that. We're good at full stack monitoring. We're good at incident response. We can always be better, but this is kind of a well-defined area that companies spend a lot of energy on. What a lot of enterprises aren't spending energy on is what happens in the software delivery chain. And it is changing rapidly. In the last 6 months, due to the result of a lot of news due to exploits in the software delivery chain, pipeline analytics has become forefront. And that is going to continue. So by joining this session, I would argue that you are ahead of the curve, and this is something that you need to think about today. Because code to cloud visibility is created as a combination of pipeline analytics, observability, and DevSecOps. And all we're trying to do is weave a thread from what we do today with monitoring your entire tech stack from infrastructure to application to front end, and tying that now to what happens in your pipeline and what happens with your SIEM. And the justification is easy. If your delivery chain goes down, you can't ship code. Very simple. No code ships if Jenkins and Spinnaker are down. So just like any application, your customers depend on this product to do their jobs. Also, your software delivery chain is a part of your attack surface. In the last 4 months, I can count 3 dramatic incidents that have happened, vulnerabilities that have exposed both the company who produces the technology and the users of that technology and all of their customers. I know that sounds very vague because I don't want to throw people under the bus, but I will give you some examples. So the first example, of course, is a large company where secrets used in their software delivery process were accessed externally and then used in production applications. So as an example of data in the software delivery chain that was exposed to exploit production applications. Another example, the IDE, of all things, the IDE, the first place where code is put together. There was a rogue IDE released that was adopted unknowingly, I assume, hopefully, by a lot of mobile application developers. They built their applications, malicious code was injected at build time, and they deployed them. This happened. They were building the vulnerabilities themselves without even knowing it because of the IDE. That is another software delivery chain attack. Another example is a large company where artifacts were injected, malicious artifacts were injected as a part of the build process. It went undetected, and those artifacts ended up in the resulting application with customers, and all the customers now had a vulnerability that was exploitable. So your software delivery chain is a part of your attack surface. If you're a developer and you think security is not your problem, the reason it's your problem is it's disruptive. Not because it's your responsibility, but it will be disruptive. You want to build code. If you're a DevOps engineer, same story. It's disruptive. If something happens in production related to a vulnerability, everything stops, and you will be a part of addressing it. And that time spent on you addressing that is taking away from you building functionality, and your cost to the organization went from value to pure expense. So that's why developers should care. I said earlier, we need to speak the same language. It is not useful to have great visibility just with your peers. That visibility needs to be shared and communicated across the engineering org, even across your product organization, and business value to your leaders. Now, that last one may be the one that was like, that's hard. Well, you know as a developer how many times you've been fighting and wanting budget to do new things, to get the new tool, to get the new monitoring tool, to get the new framework, whatever it is, testing tool. To help justify that, you can't just go to them and say that this is the best tool. From a technical perspective, they will believe you, but you have to demonstrate value. Part of demonstrating value is pipeline analytics. And part of demonstrating the value of your overall application is pipeline analytics. So understanding the impact of your features on your customers and how that impacts the bottom line of the business is also pipeline analytics. So these are all tools that in retrospect, you wish you were doing in advance. Now, the other thing is just period. How do you know you're doing a good job? How do you know that working or moving to refactoring to Kubernetes benefited the organization? Do you really know? How do you know that implementing an on-call incident response strategy reduced the number of incidents or compressed the time of recovery from mean time to detect to mean time to recover? You may have a sense, and most of us do. Most of us have a sense that we just implemented this and it is helping us. But it's very hard to report on that. And until you can report on it, it really does not exist. Next is reduction of tech debt. Tech debt is a thing that happens no matter what. And it is really hard. Now, you can do regular healthy practices of addressing tech debt on an annual, biannual basis. Or you can start to spot it in real time and address it sooner. The benefit of that, and this gets to the next point, is this shift left. Anything you can do earlier in the software delivery chain costs the organization less money. And so by addressing technical debt earlier on, this can be configuration drift, operational drift, you are actually saving the company a lot of money. Now, again, as a developer, why am I talking about all this business stuff? Well, your career as a developer, whether you're just starting or you're trying to expand into leadership, will be directly aligned to your ability to communicate what the engineering team is doing to ensure the success of the business. That's just how it works. If you're working for, especially if you're working in the private sector, the public sector, maybe it's a little different. And so having those tools, you are on the front line of being able to provide that visibility. And so having these tools in your back pocket is not only good for the business, but it's going to be good for your career and also reduce frustration for you in terms of the interruptions that you face while you're developing. And arguably, this whole concept of shift left security, shift left monitoring, shift left incident response, everything relies on pipeline analytics. So hopefully I've sold you. It shouldn't be a stretch on to why you should do it. The software delivery chain is an application. Treat it like an application. As easy as that. The good news, it's not that hard to implement. And it's probably something that you can start to approximate or start with today with tooling you already have, I hope. So really, what is it? You're monitoring your software delivery chain. You're creating a value stream and KPIs for the entire engineering organization. And you're also enabling and automating, we love to automate, audit and security, such that your compliance team, your security team doesn't need to come to you, stop everything for 2 weeks to figure out what you're doing. You can instantly point to what's going on in your delivery chain. How do you do it? Again, not very difficult. You gather metrics and logs from the tools in your tool chain. So CI/CD tools, your release automation tools, Jenkins and Spinnaker, are going to be one of the number one sources of data. Not the only source. The top sources are your ticketing system, your CI/CD tool, and your incident response tool. In some organizations who haven't implemented an incident response strategy, their ticketing tool. Once you've got the data, you correlate it across processes and teams, and then you make it observable. And that is a nuance. It's not just a dashboard you send to somebody. You have to be on the same page with the rest of the engineering organization. And it almost always breaks down into these three primary use cases. And the use cases are important because they're driven by different people and the data is leveraged by different people. So first is monitoring. Monitoring is usually driven by DevOps engineering teams, leveraged by DevOps engineering teams. Measure. Measure is usually driven by DevOps engineering and development teams and leveraged by everybody, but mostly developers. Audit. Audit is usually driven by DevOps engineering teams and security teams and compliance teams, but the data is leveraged by SREs and security teams most often. Those are the primary. Everybody in the engineering organization benefits from this, but each of these use cases have different personas who are driving it and leveraging the data. So starting with monitoring. Monitoring, again, your delivery chain is up. If it's not up, then you can't deploy code. So this is for DevOps engineers to meet their service level objectives for the delivery chain. We've already been doing this. We do this all day long with applications in production. These are your standard application and infrastructure metrics. You're going to be looking at system metrics like memory, CPU, disk, simply status. Is it up or is it down? You have red metrics on the application layer for rate, error, and duration, and use metrics for your infrastructure, utilization, saturation, and errors. This is all fairly standard, something that we are already doing today. It does change depending on if you are using a SaaS-based CI/CD tool or if you are self-hosting, self-managed CI/CD tool, like most people with Jenkins. Next is auditing. This is the one that's not the most fun. I know it's not the most fun for me. Security professionals love it. Of course, compliance teams really love it. Developers should love it for that reason, because this can be tremendously disruptive when you are asked to provide audit data for the activity across your delivery chain. The metrics I've listed here are kind of the standard activity, and they're all usage metrics. Who is accessing the tools? From where? What are they doing with it? This is especially important for your repositories and for your secrets management tools, but also for your CI/CD processes. You want to understand what data, what metadata is a part of your build processes in your repos, how it's being used. How do you make sure that a secret doesn't magically end up in a commit message in a repo? So this is all kind of standard security and compliance stuff. And just so you have confidence, you know what's going on. Security professionals will come knocking on your door for this information. Wouldn't it be nice if they never had to? And they just reference the dashboard. If something bad goes happen, they're still going to knock on your door. But it would be better to have that information readily available so they didn't have to. And finally, this is the one that everybody gets excited about, and I tend to get the most excited about as well. This is what developers really get a lot of excitement about, which is, how do you know you're doing well? There's a lot of terms in the industry used to talk about KPIs for your delivery chain. We have two primary terms that have kind of taken over. They are not standards. I will tell you right now, they are not standards, but they are good guides. So we have the Dora metrics, which come out of the Dora Institute, which at some point was acquired by Google. And these are standard metrics that came out of a lot of research they did prior to that acquisition. And you have flow metrics, which also are driven by another enterprise software company, and they are useful, mostly focused on velocity of your delivery chain. All of these are good, but none of these are turnkey. You will never be in a situation where you can just take Dora metrics or you can just take flow metrics and implement them. It is a bigger process than that. And that's the part that can kind of get frustrating at times, because it's not a technological problem. It's an organizational, and when I say organizational, I mean information organizational problem. So first, you need to decide what you want to measure, and how you decide that is really important. Developer leaderboards, for example, are really exciting, but also very dangerous for morale. What most organizations will start with is in change failure rate and mean time to resolve. So they're looking really at the incident side of it. But a lot of organizations, also the next most common is release velocity, just understanding what the release velocity, release cadence is of the entire engineering org and down to a project level. But this also can be really dangerous, because back-end services, for example, are not going to have the same release cadence as a front end. So when you compare them, it's not an apples to apples comparison. And you have to be aware of that. And everybody has to be aware of that. Otherwise, the impact of these metrics can be negative and not as beneficial as they should be. How you calculate these metrics change for every organization and every tool. There are slight variations to all of these. For example, starting with mean time to recovery. It is usually calculated by your incident response tool. It can also be calculated from your ticketing tool to, your ticketing tool. So those are your two options. The quality and the resolution is going to depend on what you pick. If you don't have an incident response tool, which is the best resolution for mean time to recovery, then the next best is your backlog. But tickets can be opened and closed for various reasons that have nothing to do with incidents. These are the types of things that you have to figure out, and no tool is going to solve for you. And it is really important to understand what these calculations are. Other metrics that I'm really excited about, besides the primary Dora 4 metrics, are work in progress, cost of downtime, and I especially really like amount of unplanned work. The reason I like amount of unplanned work so much is because it's a good indicator of the amount of disruptions your development team is facing that is not allowing them to build functionality. We also see a lot of organizations using this to audit their repositories to see if they have technical debt in their code repos, branches not being used, or weird sprawl across their branches. So this is a really exciting area, but it needs guidance and caution when you start to decide what you should measure. So let's get in the next 5 minutes on how to do this with Jenkins and Spinnaker. Both are very, very similar with different twists. Both have pros and cons. For example, Jenkins tends to be the most verbose when it comes to logs. There's a lot of data, but that can also be a problem when it comes to storage and retention with your logging tool, depending on what tool you are using. So the first step is to get the data. There's 3 primary ways to do this. A lot of it is going to depend on if your logging tool, if your visualization tool has a native integration. That is, of course, the first most beneficial place to go. If you have a native integration for Jenkins and Spinnaker, great, and they exist. If you do not, you need to get the data. One place to start is logs. Benefit of logs is great verbosity. Only with logs are you going to be able to also monitor other tools. So I'll give you an example. SonarQube. The data that comes into Jenkins logs with SonarQube test is very good. So to best visualize SonarQube activity and test results, you want to get it through Jenkins logs. You're not going to get it through the REST API. The REST API exists, but you're not going to get it via that path. So logs are greatest verbosity, but also increase the complexity of building your dashboards and increase the volume of data. REST APIs are really good. Typically, only Spinnaker and is going to be used for REST APIs and webhooks. There is a REST API for Jenkins, not commonly used, or at least from my experience. Nice way to get data in day forward. Not a great way to get historical data and extremely verbose data. And webhooks, events, are great for real-time activity in your delivery chain, but not great for historical data. The bad news is you have to pick one. You can reconcile this data with various types, various tools, but you really need to pick one and stick with it. Most organizations go with logs. Next is deciding what to measure. And that is what I already was indicating. What you pick to measure and what it means to you is very, very critical first step in understanding how you're going to do it. And it isn't trivial. Like I said, MTTR is calculated in different ways in different tools, and you need to understand that. And it can be interpreted in different ways as well. Then you build the dashboards. That's the fun part. So once you have the data, you know how you're going to calculate the metrics that you're interested in. You build the dashboards. Not terribly complex. Typical dashboards are a time series graph, historically grouped by the entire engineering org, then projects. That's going to be different based on your organization. Then there's usually almost always a trending up and down over a time period. So it's day, month, week, year. Are you trending up in mean time to recover? Are you trending down in mean time to recover? Are you trending up in velocity or are you trending down in velocity over that time? Almost always, that is the configuration across especially the KPIs. When it comes to audit and compliance, it's different. You're looking at access, percentage of people accessing from outside the country, etc. People using root policy and not using root policy because you probably shouldn't use root policy. Here are examples of 2 dashboards, and this one is Jenkins, focused on build trends over time and build times, which is really interesting because I've seen many organizations use this to optimize build times. The one above is audit and compliance, being able to see who's using the tool and how they're using it. Not terribly complex. Once you get there, start small, start very small, refine and expand. And when I say start small, I mean one metric. Pick one metric from Dora or Flow metrics and do that well and socialize it. Then expand from there. There are a lot of considerations you have to make that are not technology. And I know this is the point where you're like, why aren't you showing me implementation in code, Chris? Well, one, because it's tool specific. So if you want to see that, I need to know what tools you're using. But two, there's a lot of technology considerations that are not the technology itself. First is data resolution. Your resolution increases as you correlate two tools together. Repo to CI/CD, Jira or your backlog to your CI/CD. Tool sprawl. If tool sprawl is a problem in your organization, you need to focus on specific tools. You can actually use this as a lever to get people to adopt tools correctly. Your deployment strategy. Your deployment strategy will dictate how you measure things like deployment frequency, because canary releases and rollbacks for canary releases may not be, to your organization, considered a failure. And project organization. Naming conventions. It's a crazy thing. So simple. But if you don't have good naming conventions for your teams and your projects, it becomes very complicated when you look at your builds and your pipelines to understand what applications are being deployed, what teams are doing it, and correlate that data in a meaningful way. Thank you so much. 30 minutes. I have a lot more to talk about this topic, so if you want to talk more about pipeline analytics, please reach out. Let me know. Let's discuss. This is a topic that's really important to me, and I guarantee you in the next year is going to become more and more common. Enjoy the rest of the event, and thanks for attending my session.